Today we will discuss that name reaction from haloalkane and haloarenes. First one, darzen procedure. DARZN, darzen procedure. Now alcohol reacts with SOCl2 thionyl chloride to give corresponding halide. See, CH3CH2OH ethanol plus SOCl2 thionyl chloride, and in presence of pyridine. What will be the product? Now see, ethyl chloride SO2 plus HCl. Now what is the function of that pyridine? It will absorb that HCl. Okay, that is the function of pyridine. It will absorb that HCl. So that is darzen procedure. Now what is the advantage of this? Now see, that ethyl chloride, that one liquid, but other two are gaseous byproduct. So we can easily separate out the main product. That is the advantage of that darzen procedure. There are many chlorinating agents, PCl3, PCl5, but what is the advantage of darzen procedure? Now byproduct are gaseous, main product liquid. In Finkelstein reaction, see, now halide, alkyl halide converting to alkyl iodide in presence of sodium iodide, NaI, that is the reagent, and that medium, that acetone, and you have to reflux. So see, now Rx plus NaI, that is our reagent, sodium iodide, NaI, in acetone medium, that is important, acetone medium, and we have to reflux. We will get Ri plus NaX. Now in this case X is chlorine bromine. So alkyl halide to alkyl iodide, that one Finkelstein reaction. Next one, Swarts reaction. Now in this case, that alkyl halide converting to alkyl fluoride in presence of certain fluoride salt like silver fluoride, mercurous fluoride, Ag2F2, cobalt fluoride, antimony fluoride. By using this salt, we convert alkyl halide to alkyl fluoride. If you take methyl chloride plus AgF, silver fluoride, what will be the product? Now see, CH3F plus AgCl. So Swarts reaction, it convert alkyl halide to corresponding fluoride. Now what are the salt used? Now AgF, Ag2F2, COF3 cobalt fluoride, and antimony fluoride SbF3. These salt we use: silver fluoride, mercurous fluoride, cobalt fluoride, and antimony fluoride. Hunsdiecker reaction. Now in this reaction, silver salt of carboxylic acid, it reacts with bromine in presence of CCl4 and give corresponding that bromine, alkyl bromine. Now see, if we take silver acetate, CH3COOAg, silver acetate plus Br2. Now CCl4 medium, that non-polar solvent CCl4 medium, and what will be the product? Now see, CH3Br plus CO2 plus AgBr, and we have to reflux the system. That is Hunsdiecker reaction. Now you can remember that mechanism in that way. See, this bond move here to it forms CO2, C double bond O, that also becomes C double bond O, so CO2. So this bond attack that bromine. So this part CO2, CH3Br, Br minus Ag plus, it will be AgBr. Okay, if you remember reaction mechanism, you do not have to memorize that reaction. This bond move here, this bond attack that bromine, and it release that Br minus Ag plus, it form AgBr, this part CO2, and that is CH3Br. Simonini reaction. Now here also silver salt of carboxylic acid. Now here we need that 2 mole of silver salt of carboxylic acid. It reacts with iodine. What will be the product? Now ester plus AgI plus CO2. Now what is the reaction mechanism? See, reaction mechanism, see, first step that similar to that Hunsdiecker. Okay, see, in first step what happened? See, first step same as Hunsdiecker. So first step it will form Ri plus CO2 plus AgI. Now that Ri, iodine ki size more, so that bond is unstable, that Ri bond weak bond. Okay, so that Ri, that act as a electrophile. See, so next step, another molecule of silver salt, see, it act as a nucleophile, and that Ri, that act as a electrophilic center. See, so see, the ultimate product is ester. Okay, first step similar to that Hunsdiecker. Second step, as Ri is unstable, so another that carboxylate ion attack that Ri and it form that ester. Sandmayer reaction. But before Sandmayer reaction, we have to learn diazotization reaction. Diazotization reaction. Now see, aniline reacts with NaNO2 HCl in 0 to 5 degrees Celsius. It will form benzene diazonium chloride, N2 plus Cl minus, benzene diazonium chloride. Now this reaction is diazotization. Actually in Sandmayer reaction, starting material is benzene diazonium chloride. So first you have to learn that diazotization reaction. Now in Sandmayer reaction what happens? See, now that benzene diazonium chloride, copper salt and that halogen acid CuCl HCl, what will be the product? Now chlorobenzene. So in presence of CuCl HCl, it produces chlorobenzene and nitrogen, that is Sandmayer reaction. Now gatterman reaction, now instead of copper salt, if we only use copper, now in Sandmayer reaction we can prepare chlorobenzene as well as that bromobenzene. In that case we have to take CuBr and HBr. If we want bromobenzene, we have to take CuBr and HBr. In gatterman reaction, see, instead of copper salt we have to use only copper, metallic copper. In benzene diazonium chloride, see, copper HCl. Gatterman only copper, Sandmayer copper salt. That is the difference between Sandmayer and gatterman reaction. Next, boil cement reaction. Now in this case, see, benzene diazonium chloride reacts with HBF4 to form that diazonium fluoroborate, benzene diazonium fluoroborate. That one on heating produce fluorobenzene. And byproduct BF3 and nitrogen, that is the byproduct. So diazonium chloride, benzene diazonium chloride first reacts with HBF4 to form that benzene diazonium fluoroborate. That one on heating produce fluorobenzene, that is our main product, fluorobenzene. Raschig process, industrial preparation of chlorobenzene. Now benzene plus HCl plus half O2 in presence of CuCl2 and 525 Kelvin temperature, it produce chlorobenzene and that water vapor. That is industrial preparation, Raschig process. Benzene reacts with HCl and half O2 in presence of CuCl2 and 525 Kelvin. It produce chlorobenzene. So these are the name reaction from that haloalkane and haloarene.